All right. So we're making reasonable time here. We're now moving to the fourth segment, which is about Duke in space. Okay, that was really bad. Sean Phillips, would you like to come up on stage? There we go. Hey, Sean.
Hey.
So before we start, I understand that, all we're doing here is really cool, but your trip here is actually sponsored by NASA, isn't that correct?
That's correct. I get to do all this here on NASA's benefit, and I get to go home and keep working for him.
That's just, like, I need to change the job.
Yeah.
Anyway, you also had some message you wanted to share with us?
Yeah, I'd like to thank the people that made that possible back there. I'd like to thank our manager on the mission, Conrad, and I'd also like to thank Russell, who gave me the go-ahead to let this vision keep going 2 years ago.
All right, so big thank you to NASA for sponsoring Java. Now, you have something cool to show us. Why don't we jump straight into that? Can we roll the video? So can you tell us what we're seeing here?
Okay, so what I'd like to show you is the MMS mission. This is a mission that's going to launch in November of 2014, and it measures the magnetosphere. And the magnetosphere, that's the magnetic fields of the Earth, and they protect us from the solar radiation and the sun's winds.
So what is this little strange shape we're seeing on the screen here?
We see 4 spacecraft here, and they fly in a formation, which is necessary for the science of the mission. And it's our job, AI Solutions, to provide all the software and the science necessary to keep the formation intact so it can do its job.
You say this is science. I think it looks like a death ray machine or something.
Well, it's actually the 4 spacecraft. They form into this gigantic Voltron robot that guards us from space. That's why the budget's tight.
Oh, okay, that makes sense.
Yeah.
So so this is a great science mission. What exactly are you doing? You said you support like mission control and a few other.
That's right. That's right. We make software that in the ground systems that provides flight dynamics, and the GGSS, which uses Java, performs a lot of QA for the telemetry of the spacecraft and also produces configuration and maneuver commands.
Right. And you also handle launch control?
Yes, AI Solutions also does launch services out of several locations, including Kennedy, Vandenberg.
Awesome. And so since we're releasing Java 8, can you help us with the launch?
Yes, that's right. It's a big release, so we'll have to get a big rocket and maybe rename it
J-Rocket.
I was thinking Java SE could be Space Edition now, maybe. I don't know.
Okay. Yeah, that's bad. Thank you. All right. So what's happening now? I know this thing is going to start moving.
Right. We're close to the top of the altitude, which is halfway to the moon. It's really high up. And this is the area where it needs to be to perform its science. And so the green coloration indicates that it's in a good formation. But what's happening right now is that actually now we're falling back down to Earth in a controlled fashion, and we're going to be picking up a lot of speed. It's here that our Java software receives telemetry products and then checks out and says, okay, are these spacecraft in a good way or not? And unfortunately, right now, we're about to swing around the Earth at a very high rate of speed at 14 kilometers per second. And as we pan the camera around, we see how deformed that pyramid gets. It cannot be in this formation, that, looking like this super Star Destroyer here, to do what it needs to do. So as it comes back around, we can again speak to it again, and we can run a whole series of very, very complex simulations and analysis and perform the maneuver planning necessary to maneuver those spacecraft back into the formation that they need. Those maneuver commands go back up to the spacecraft, and then the tetrahedron reforms and goes back up to the top of the altitude, where we'll see it again in a few more days.
So there's only a short window of time during which you do the kind of communication, right? So you hope there's no garbage collection happening, right?
Well, that's right. Yeah, memory management is important, but Java's helped me a lot to do that, actually.
How long is the window?
It's about 90 minutes, give or take the phase of the mission. So there's not a lot of time.
I don't think I've ever seen a GC pause that long. No. All right, do you want to show us a demo as well?
Sure. Yeah, I think we're done with that.
I think we're done with that. So let's go to the demo. Ooh.
There we go. Okay, so what you see is a live view of the GGSS, and I have some interesting graphics up here. And the NetBeans platform has enabled me to do a lot of this good work and produce a lot of these data products. And JavaFX has allowed me to take those same data products and then visualize them in an interesting way, in a very easy way. So I can reach over here and I can drag things into my charts and get interesting visualizations out of those. In interesting combinations. Maybe not necessarily something that the analyst or the operator had considered. And then if I want, I can take these sliders here and I can only look at one segment of the orbit. And what I'm doing is I'm injecting all the orbital elements in the data over here into this 3D view. And it actually shows me the time that I selected over here on the left highlighted here. And this particular orbit pattern is from a simulation generated for the MMS mission.
Very cool.
Yeah.
All right. Well, thank you, Sean. So you're using a whole slew of Java technologies here.
That's right.
JavaFX,
JavaFX.
NetBeans, Java. Is Java running in the spacecraft?
No, Java is not running on the spacecraft. That is a Goddard NASA product called GEONS. It's been in development for quite some time. But we do use NetBeans to test and validate that source.
Well, I hope that Java 8 and the modularity and compare profiles is going to help make it lighter so we can launch it into space.
Maybe. I can't promise that, but I'll see what I can do.
We'll work on it.
All right.
Thank you. Awesome. Thank you,
Nice.
Sean.